Good day, everyone. My name is Nik Ashri Nik Harun, and together with my co-author Nik Ashri we are going to be presenting our paper entitled From Framework to Practice, a guideline for implementing AI tools in design courses in higher education. This presentation discusses how AI tools can be integrated into design courses in a more structured, responsible, and pedagogically meaningful way. Rather than treating AI simply as a new digital tool, this paper focuses on how educators can guide its use so that students maintain authorship, critical judgment, and creative agency throughout the design learning process. AI tools are increasingly being used in design education. In design courses, students may use AI tools for brainstorming, visual exploration, reference building, rapid prototyping, and critique support. For example, generative AI can help students quickly explore visual possibilities, test different concepts, or develop initial references before refining their own design direction. However, the educational value of AI does not depend only on what the tool can generate. It also depends on how the tool is positioned within the learning process. In design education, the goal is not only to produce polished visuals, the goal is also to develop conceptual thinking, visual judgment, authorship, craft, and reflective practice. Therefore, AI needs to be introduced in a way that supports learning, not replaces it. When AI tools are introduced without clear guidance, students may become overly dependent on generated outputs. They may also adopt AI-generated images without enough transformation, or become unsure about authorship, originality, and acceptable use. This creates several problems in design education. First, the student's creative contribution may become unclear. Second, the final output may appear visually polished, but the learning process behind it may be weak. Third, students may not know how to disclose AI use or how to credit sources responsibly. So the problem is not simply that students are using AI. The problem is that AI use can become unstructured, undocumented, and difficult to assess. This is why educators need a practical guidelines that helps them define how, when, and why AI should be used in design learning. This paper builds on a previous reflective framework developed from classroom experience in AI-assisted creativity and design education. The earlier framework identified several important dimensions for implementing AI in design courses. These includes AI literacy, positioning, equity supports, workflow guardrails, process evidence, and self-assessment. At the center of this framework is student creative agency. This means that students should remain active decision makers. AI should support their thinking, but it should not become the source of creativity or the final authority in the design process. In this paper, we move from the reflective framework toward a more practical implementation guideline. In other words, the paper asks how this framework can be translated into actions that educators can use when planning, facilitating, and assessing AI-supported design activities. The proposed guideline is organized into 7 interrelated areas. These are AI literacy, pedagogical positioning, equity supports, workflow guardrails, process evidence, assessment and self-assessment, and governance and ethics. Together, these 7 areas help educators structure AI use in design courses. They address not only technical use of AI but also the pedagogical, ethical, and assessment-related aspects of AI-supported learning. The center of the guideline is the student authorship, judgment, and creative agency. This is important because AI should not be positioned as a replacement for students' design thinking. Instead, AI should be used as a support for exploration, reflection, and development, while students remain responsible for interpreting, selecting, rejecting, modifying, and justifying their design decisions. To explore more on these 7 areas, I will pass the presentation to my co-author, Nur Asfarina.
The first area is AI literacy. AI literacy should be introduced early in the course before students use AI tools in their design work. This includes helping students understand what AI tools can do, but also what their limitations are. Students need to understand that AI-generated outputs may contain bias, inaccuracies, repetitive aesthetics, or assumptions that do not fit the design brief. Therefore, they should not accept AI outputs passively. In a design course, AI literacy should not be limited to technical training. It should also involve critical questioning. For example, students can be asked to compare several AI-generated outputs and discuss which ones are useful, which ones are problematic, and why. Through this activity, students learn that AI outputs require interpretation, evaluation, and transformation by the designer. The second area is pedagogical positioning. This means that educators need to clearly define the role of AI within the design learning process. AI should be positioned as a support for specific stages such as brainstorming, reference building, early visual exploration, rapid prototyping, or critique. It should not be presented as a source of creativity or as a final design solution. For example, in a design project, students may use AI after they have analyzed the brief and developed initial ideas. AI can then help them explore visual alternatives. However, the students must still decide which elements are relevant, what should be rejected, and how the idea should be developed further. By making AI's role explicit in project brief and rubric, educators can help students understand that AI is part of the process, not a substitute for the process. The third area is equity supports. Students do not enter the classroom with the same level of technical confidence, digital skills, or access to AI tools. Some students may already be familiar with AI platforms, while others may feel uncertain or anxious about using them. If educators do not provide support, AI use may benefit students who are already technologically confident and disadvantage those who need more guidance. Therefore, AI implementation should include demonstrations, tutorials, low-stakes practice tasks, and time-boxed experimentation before graded assignment. The purpose is to create a shared foundation. Students should have opportunities to experiment, make mistakes, ask questions, and understand the tool before they are expected to use it in assessed design work. In this way, AI becomes a shared learning resource rather than a source of unequal advantage. The fourth area is workflow guardrails. Workflow guardrails define acceptable and unacceptable AI use in a design project. This is important because students need clear boundaries. Educators can specify when AI may be used, how prompts should be developed, how many iterations are allowed, and what types of AI use are not acceptable. For example, AI may be allowed during early ideation or reference exploration, but students may not submit an unmodified AI-generated image as their final design. Similarly, students may be required to disclose their prompts and explain how AI outputs will transform. Guardrails help prevent aimless generation and over-reliance. They also help students understand that AI use must be intentional, documented, and connected to the learning objectives of the course. The fifth area is process evidence. This is especially important in AI-supported design education because AI tools can produce visually polished outputs very quickly. If educators assess only the final image, it may be difficult to know what the students actually learned or contributed. Therefore, students should be required to submit evidence of their process. This may include prompts logs, sketches, AI-generated evaluations, annotated boards, design journals, screenshots of iterations, and short reflective memos. These materials help make students' authorship visible. They show how students selected, rejected, modified, or transformed AI-generated material. Process evidence also helps educators assess the quality of thinking behind the work, not only the surface quality of the final outcome. The sixth area is assessment and self-assessment. In AI-supported design work, assessment should focus on not only visual polish, but also on judgment, originality, transformation, rationale, and reflection. This means that rubrics should reward students for showing how they develop their ideas, how they respond to critique, how they transform AI-assisted material, and how they justify their final design decisions. Self-assessment is also important. Students can be asked to explain which parts of the work were supported by AI, which parts were developed independently, and how AI influenced their decisions. For example, Students may answer questions such as, what did AI help me generate? What did I change? What did I recheck? What is my own design contribution? This encourages students to remain accountable for their creative choices and to understand AI as one tool within their broader design process. The seventh area is governance and ethics. Responsible AI use should not be treated as a final reminder at the end of a project. It should be embedded into the course structure from the beginning. Educators need to set clear expectations regarding disclosure, attribution, privacy, bias, originality, and acceptable use. Students should be required to declare how AI tools were used. They should also consider whether AI-generated outputs reproduce stereotypes, cultural inaccuracies, or problematic visual assumptions. Another important issue is data privacy. Students need to be careful about what images, texts, or references they upload into the AI systems. By making governance and ethics explicit, educators can help students use AI more responsibly while maintaining academic integrity, authorship, and critical awareness. This paper is conceptual and practice-oriented. It proposes guidelines based on prior reflective practice and classroom experience, but the guideline still needs to be tested and refined across different educational contexts. Future work may involve applying the guideline in different design disciplines such as visual communication, production design, costume design, fine art, digital media, or product design. Further research could also gather feedback from students and educators, compare different AI-supported assignments, and examine how the guideline affects students' process documentation, ethical awareness, and creative decision-making. Through future classroom implementation, the guideline could be refined to better respond to different cohorts, tools, institutional policies, and design learning environments. To conclude, this paper argues that AI can support design learning when its use is guided by clear pedagogy, process evidence, assessment, and ethics. The proposed guideline helps educators move from experimental AI use toward more structured implementation. The key point is that AI should support, not replace, design thinking. Student authorship must remain visible, and students should continue to exercise judgment, interpretation, transformation, and reflective decision making. By organizing AI implementation through the seven guideline areas, educators can create learning activities that are more transparent, responsible, and pedagogically meaningful. Thank you.